The purpose of the life scale printouts is so that you can have a chance to play around with different orientations of your parts. It'll take many iterations before you end up with something that you really like. I think over the summer we had at least 4 or 5 iterations. I'll remember to bring some to class so that you can see some of the different CNC cuts and 3D prints that we had over the summer. But even with my experience, I still go with a cardboard prototype first and lay things out on paper first. Even though I know some things, like I know that I'll want my motors sort of near the front. Your typical what's called differential drive robot, we'll talk more about differential drive dynamics when we get to kinematics in a couple of weeks, works best if your motors are in front and your caster ball, something that just sort of glides on the ground, is in the back. So the caster ball here, this piece, is something that would mount to the underside of the chassis. And just to spoil a bit of the fun going forward, I laid my parts out and I have a couple of laser cut chassis with the different part names engraved in them, just so I very clearly don't forget where each of my different parts belongs. So I usually start with the motors. I'll place them there and I'll put my caster ball at the back so that it has sort of a tripod to balance on. And then my largest components would be the microcontroller and expansion board and the battery battery holder. The battery holder I usually put on the underside as well. We could put it on top, but if we have all of our parts on top, it just makes everything more likely to get in each other's way in terms of wires, and it just makes the whole thing a little bit larger. Now, we don't have to make it as small as possible, but I don't think, a foot by 8 inches is something that we'd want to go with. So instead, I usually start by positioning my microcontroller, because everything sort of stems from plugging into the microcontroller. It might be tempting to try to put it here in the front, but one of the reasons that I lay these out this way is that I can look at the picture here and I can see that, okay, well I have a USB connector here on the side, and that's going to interfere with the wires coming out of the top of the motor here. So I can't really orient it like this. Orienting it like this means that I can have the USB connector coming in through the top or the front, but now I'm going to have trouble getting to these I2C ports on the side, and if I have a bunch of wires sort of connecting from here over to here, it's going to be hard to get access to the expansion board's power switch here on the side. So I opted for putting that about here on my version. So if we look at my chassis, I've got motors here on the front, and my expansion board's back here in the bottom right corner, just to sort of be tucked out of the way. Once that was placed, the next large component to place was the breadboard. And I looked at a couple of different orientations for the breadboard and ended up just liking putting it sort of right here in between the motors and near the front of the robot. Sort of out of the way, still easy to access, getting wires connected from the microcontroller to the breadboard, and also from the motors to the breadboard as well, which I knew was something that we would have to do. This one doesn't have the same problem. There are no wires coming in from the sides. All the wires are going to be jumper cables that sort of bridge over from the top. This style of jumper cable here. So we can see something like connecting from here to here. The battery holder I opted to put underneath. And one nice thing about having things mounted underneath and then also using standoffs to lift things off the board is I can actually put my expansion board over top of these things as long as the holes don't interfere with where this thing is mounted directly up against the underside of the chassis. So I couldn't put these two here because I wouldn't be able to have a bolt go through this hole. However, I could put it sort of like here. A bolt here, and on the underside, these two holes can be used because this is going to be mounted standing off of the chassis itself. Same with putting something over the caster ball here. So in my version, I've got it opted to be laid out a little bit like this, and like this. That's about as compact as I could put it while also putting other parts on there that you don't have to worry about quite yet. So for example, in the previous iteration, off the front I've got a mount for the LiDAR and the camera. And the camera itself has to be connected onto the board, and there's a vision module, artificial intelligence vision module, that will also mount onto the top of the chassis. If you'd like a preview of what this will look like after assembly, ends up looking like this. A few differences from what you'll end up with. For one, I have a nice screen on top of my microcontroller and the expansion board, and this one has a film on it that I haven't taken off yet because I wasn't sure if I would go with this one or the one that I custom designed out of acrylic that you can, I'll put this part on the course website, and you can cut this out of acrylic at the makerspace if you want to put a protector over your expansion board, which I highly recommend. I actually think mine turned out a little bit better. I had it before I had the official one. Mine has a cutout here for the antenna, and it's difficult to see here. You'll see it in the video of me assembling this. The antenna, the only place to put it was sort of underneath this shield. It's a little uncomfortable to have the antenna just sticking out right here, but we'll have to make do with that. A couple of other things you'll notice when I'm fast forwarding through this thing being assembled is I tugged on the black wire too hard and broke it off of the voltage tester, so I had to go back to my lab and resolder that on there. If anything like that happens while you're assembling, just let me and the TAs know, and we'll make sure to give you either a new replacement part or help you get yours repaired. Two other things to note since I'm talking about the antenna. The antenna can be stuck to something. It has like an adhesive on the back. Don't do that. I want to be able to reuse these antennas for future semesters, and I don't want them stuck to something. Likewise, the breadboard itself on the underside has something you can stick to the cardboard or any other material. But again, I want to be able to reuse these. So please use the bolt holes, and there will be bolts supplied for everybody in the class. Please use the holes to mount these to something. Do not stick them to anything. At all costs, do not do that, because they are pretty much impossible to reuse once you've done that. And they're, a surprisingly large cost out of this entire kit. Something else to notice, I'll point out the standoffs. So this is what I mean by the expansion board not being directly against the chassis. These little white pieces here and here are the standoffs. So we have a standoff keeping the bottom of the chassis off the the bottom of the expansion board off the chassis, and a standoff for raising the cover from the lower part of the PCB itself. The rest of this video will be just me sort of struggling to assemble this thing. I'll put it at a faster speed and give you some background music for it. Feel free to skip that unless you want to see me shake my hands a few times, because it was pretty frustrating at a couple points, particularly when I accidentally unplugged the voltage tester wire.